Okay, here we go. Statistical inference number 4. We've already looked at the underlying logic of Aunt Belinda. Here comes underlying logic in general, though we will not leave Aunt Belinda behind. And of course, look out, philosophy's a-comin'. To remind us about good old Aunt Belinda. If Belinda has no powers and the coins are fair, then you get 6 to 14 heads in 20 flips. And you can see the picture in the Euler diagram. That is, if it's in the yellow circle, it must be in the blue circle, except for the little exception sliver. But if it's outside the blue circle, like if you get 16 heads, then the first box has to be false. And the way that that can be false is either she has some powers or the coins are not fair. All right, moving on. That means the upper left-hand box is the null hypothesis. The one in the lower right is the test statistic. And the one in the lower left is what happens when we reject the null, that is, when the null is false. You might wonder about the box in the upper right. If you get something that's in that 6 to 14 range, that means it's in the blue circle. And then you can't tell anything about the yellow circle. It could be in or out. So we'll see what that means. But first we're going to look at science in general. Here's an idea of a science project you might have done in middle school. You have this notion that if the density of an object is low, if it's low density, and will be numerical here, if it's less than or equal to 1 gram per cubic centimeter, which is the density of water. If that's true, low density, that means it will float. Okay, here's the Euler diagram for that. If the density is less than or equal to 1, it floats. There may be other ways to make it float. But if it sinks, it's outside the float circle, and that means that the density is greater than 1. This leads us to an important generalization. This is going to seem a little strange at first, but watch this, it's very cool. If we have an idea about the way things are that you cannot observe directly, that idea will have consequences in observable facts. So you can't really tell what the density of an object is without making a bunch of measurements, but it has an observable consequence. If it's light, it will float. And we can use that in order to disprove that it's actually light. So let's look at this again here. Here's science in general. If the density is less than or equal to 1, then it floats. That's what the Euler diagram says. But if it sinks, we can say that the density must be greater than 1. So we have an idea, and it implies facts. But the key thing is, you can't prove the idea. You can only disprove it. So if you're outside the circle of those facts, you know that the idea is false. But if you're inside the circle of facts, you don't know whether the idea is true or not. Okay, let's apply what we just saw in science to the statistical situation. And here we are with Aunt Belinda with her 6 to 14 heads and the idea that she must either have power or the coins are not fair. And this idea of the powers is the thing which we cannot observe directly. We can't open up Aunt Belinda and see that, but we could disprove that. So what we need to do is, when we're doing an investigation in statistics, we want to make the thing in the yellow box something we want to disprove. We observe something interesting, so we want to put something uninteresting in the yellow box. So it's not very interesting if the coins are fair, so that's what we put in the yellow box. Furthermore, we want to make it easy to model whatever we put in the yellow box, so easy to simulate in our case. And finally, that thing in the yellow box, that's the thing that becomes the null hypothesis. So if we look at the Euler diagram again, we have data on the outside, the null hypothesis on the inside. All right, let's give another little example of this. So suppose you notice that men earn more than women. That's something that's interesting. What would be not interesting is men earn the same as women. That's the thing we want to disprove. So we're going to do a scramble, which will make men earn the same as women. That's how you make two groups the same. That'll make the null hypothesis true. And we're going to compare the observable fact, the test statistic, which is your measure in fathom, to the results of the scrambling. If it's outside the results of the scrambling, then the blue circle becomes implausible, and you know that the null hypothesis must not be true and will reject it. That's the overarching logic of everything we've been doing lately. Maybe we'll take another little look at it in another video.